Carbon capture technology, including both carbon capture and storage, CCS, and direct air capture, DAC, has emerged as a critical strategy for mitigating climate change by reducing carbon dioxide (CO2) emissions. These technologies aim to capture CO2 emissions from industrial processes and ambient air and store or utilize them in various ways. Let's delve into the methods of carbon capture. First, carbon capture and storage, or CCS. This method involves capturing CO2 emissions from industrial sources such as power plants, cement factories, and steel mills. Various capture methods are employed, including post-combustion capture, pre-combustion capture, and oxy-fuel combustion. Once captured, CO2 is transported and stored underground in geological formations such as depleted oil and gas reservoirs or deep saline aquifers. Moving on to direct air capture, or DAC. This technology removes CO2 directly from the ambient air using chemical processes or absorbent materials. The captured CO2 can be stored underground, utilized in industrial processes, or converted into valuable products. Now, let's explore the storage and utilization of captured carbon. First, underground storage. CO2 captured through CCS or DAC can be stored underground in geological formations where it is permanently sequestered, preventing its release into the atmosphere. Common storage sites include depleted oil and gas reservoirs, deep saline aquifers, and minable coal seams. Next, industrial utilization. Captured CO2 can be used as a feedstock in various industrial processes, such as enhanced oil recovery, production of synthetic fuels, and manufacturing of chemicals and materials. Utilizing CO2 in these ways helps to reduce reliance on fossil fuels and mitigate CO2 emissions. Let's explore the potential applications of these technologies, particularly in the context of climate change, mitigation, and hard-to-abate sectors. First, climate change mitigation, carbon capture, and storage, or CCS, along with direct air capture, or DACE, technologies offer significant potential for reducing CO2 emissions and mitigating climate change by capturing and storing CO2 before it even enters the atmosphere. These technologies can play a crucial role in achieving carbon neutrality targets and limiting global warming. Now moving to the hard-to-abate sectors, CCS and DAC provide options for decarbonizing sectors with challenging emissions reduction pathways such as aviation, shipping, and certain industrial processes. They offer a pathway to achieving negative emissions by removing CO2 from the atmosphere, particularly through bioenergy with carbon capture and storage known as BCCS. In conclusion, carbon and air capture technologies hold promise for addressing the challenges of climate change by capturing CO2 emissions from industrial processes and ambient air and storing or utilizing them in various ways. Continued research, technological innovation, and policy support are essential for advancing these technologies and achieving widespread adoption at scale. Thank you for watching this video. I will meet you again in another interesting video.